It is 5-3. Yep. Because 5-1 is opposite sides are congruent. 5-2 is opposite angles are congruent. And 5-3 talks about the diagonal. So 5-3 lets us say that 6x minus 5 equals 4x plus 3. Subtract 4x from both sides. That will give me 2x. Add 5 to both sides. Equals 8. X equals 4. We should have a 4 there. Boom, boom, bam. Questions, comments, concerns? All right, let me preface this with a statement. Trapezoids are not parallelograms. Parallelograms need both opposite pairs being parallel. A trapezoid is a quadrilateral, so it does have 4 sides. But it has exactly 1 pair of parallel sides. A parallelogram needs both pairs being parallel. This one has exactly 1. So a trapezoid is completely different than a parallelogram. These two things are definitely not parallelograms. So we can't use parallelogram theorems or rules on trapezoids. So they're going to have their own statement. So let's name some stuff. All right, the parallel side, the sides that are parallel are going to be called your bases. And it doesn't matter which direction they're drawn. So if we look at the one that the parallels are top and bottom, both of those would be bases. That's a base. That's a base. And if I rotate it, the 2 parallel lines are still bases. So base does not mean it's on the bottom. It just means it's one of your parallel pair. All right, the other sides are called legs. Legs. They hold up the bases. Like a leg, yeah. Thanks, Songha. So we have bases and we have legs. Bases are always the parallel side. Doesn't matter which direction I draw it, the parallel sides are your bases. And legs are the other 2. It's important to know that because we use that to describe certain things. So we're going to talk about an isosceles trapezoid to start off with. And in fact, we're going to go way back and talk about an isosceles triangle. And we said if I have an isosceles triangle, that means both legs are congruent. And it means that base angles are also congruent. Well, a triangle isn't that far away from a trapezoid. Because if you just picture drawing a parallel line here and cutting this off, you have an isosceles trapezoid. And that's what we're going to draw on the other side here. We're going to draw an isosceles trapezoid. So we have 2 parallel lines. And just like an isosceles triangle has congruent legs, an isosceles trapezoid is also going to have congruent legs. Maybe I should put parallel lines on here, saying that those are parallel. That's what makes it a trapezoid. In an isosceles triangle, base angles are congruent. In an isosceles trapezoid, base angles are congruent. So base angles are congruent. The big difference is an isosceles trapezoid has 4 base angles. These are not the only sets of base angles. Remember, this is a base too. This is a base. This is a base. So you also have base angles up here. Make sure you put your 2 marks on there because all 4 angles are not congruent. It just means the 2 on the bottom are congruent and the 2 on the top are congruent. And that leads us to Theorem 518, which is on your sheet. So on that sheet that you can use on your test, it specifies that if you have an isosceles trapezoid, your base angles are congruent. So it might be a good idea to have that drawing on there. Something like this, showing that x and y are congruent. But on top of that, A and B must also be congruent. Don't mess this up. Not every trapezoid is isosceles. To be isosceles, it has to have congruent legs, just like an isosceles triangle. This one probably isn't isosceles, and this one is definitely not isosceles. All right, so you have to specifically know it's isosceles. Either I tell you, or I put the two little tick marks saying that they are congruent legs. All right, so there has to be a congruent leg in order for it to be isosceles. All right, medians. What does a median mean in a triangle? What's a triangle median? What's a triangle median? What's a median in a triangle? We talked about the last 3 days. Yeah.
It's a line that goes from a vertex to a midpoint.
To the midpoint, right? From a vertex to a midpoint. That's what we have. A line segment joining a vertex to the midpoint on the opposite side. How many medians does a triangle have? What do you got? 3. There are 3. There are 3 medians. Because we have 3 vertices. If I go from that vertex to over here, that's a median. Make sure you put your little tick mark saying that that is a midpoint. And then you just repeat the same thing for all your vertices. Go to that midpoint, put 2 tick marks. And finally, my last vertex. I'm going to make sure to put 3 tick marks so I know that each one of those is, in fact, a midpoint. So median to me always means midpoint. Median, midpoint. Median, midpoint. Same thing goes for a trapezoid. However, we don't have a ton of medians we can deal with. With a trapezoid, it's just going to be a segment that joins the midpoints of the legs. Just the legs. So it is going to be the segment that joins the midpoint of the legs. So the first thing we're going to have is 2 midpoints on our legs. Remember, our legs are the ones that aren't parallel. So maybe I'll put parallel symbols on the one on top and bottom. That must mean the other 2 are our legs. Find midpoints of those. Put little tick marks to show that those are in fact midpoints. All 4 sections will not be congruent, so you shouldn't put a tick mark on each of them unless it's an isosceles trapezoid. And then we just draw a line. Well, here's something important about that line. It is parallel to the other 2. And it shouldn't blow your mind too much that it's parallel. Picture this as a triangle. We have those triangle rules that if I connected the midpoints of the legs, it was half of that, and it was parallel. So the parallel makes sense, that it has to be parallel. So there's 1 median there, or yeah.
So is that 2 thirds of the bottom parallel?
Not quite. We do have a rule. So it can't be half, right? It can't be half because if you picture, if I had the full triangle, this line would be up higher. So half doesn't quite work of the base. If this was a triangle, it would be half. You are correct that it should be something else. And it does say here, it is going to be half your average. So first of all, it's parallel to the bases. This is Theorem 519, so once again, you can use this on your test. So you have all this information in your hands on the test. It's parallel. But more importantly, to figure out the numbers, it is going to be the average of your 2 bases. So you're going to do base 1 plus base 2, and then you're going to divide by 2. So it's base 1 plus base 2, and then you're going to divide by 2. Let's make sure we stay up. We're missing a whole bunch of notes. So in here we have SR plus PQ times 1/2. How that's going to work with numbers? Well, I'm looking for x. Your median, which is x in this case, is going to equal 1/2 base 1. I'll call that my PQ, so I'll call it 16, bless you, plus 6. Well, x is going to be 1/2 of 22. X is going to equal the big old 11. Whoa is right. This one's a little different. Our median this time is 13. We're still going to plug it into the equation just like we did. So we are going to say 13 in this case equals 1/2. My base 1 is 21 plus my x. Now, we could distribute this 1/2, but then I get 10.5, and then I have x over 2, and I have to deal with that. How can I get rid of that fraction before I even have to distribute it? So I'm going to multiply by 2. So what we're going to do is we're going to take this whole thing, maybe I should put that in a bracket, multiply it by 2, which means I need to multiply the other side by 2. Maybe I shouldn't put x's. It almost looks like x's. It is multiplication. So my left side is going to equal 26. Now here is the thing I noticed from my other class. They distribute this 2 to everything. This is all a chain of multiplications. This is 2 times 1/2 times 21 plus x. This doesn't get distributed to everything. It's just 2 times 1/2 equals 1. So these cancel each other out, and you're just left with 21 plus x. Then we subtract 21 from both sides, and we get x equals 5. Do the next one. If you haven't already, do the next one. What does x equal in the next one? If you got it. Sunga.
I got 9.
You got 9? Then we get something different? No one got 103? No one got like 1,000? Let us check it out. All right. How do I know 10's a median? I mean, I'm not 10, but how do I know that segment that has a length 10 is a median? How do I know it's a median? Because you have to know it's a median before you can even use any of these properties. Yeah? The sides are split directly in half. So these two things must be midpoints, right? And if both of them are midpoints, then we have a median. As soon as I know it's the median, it means the median is going to equal 1/2. Now I put these in brackets. My x minus 3 plus my 2x minus 4. Well, I'm going to simplify what's inside those brackets first. So we'll have 10 equals 1/2. What's in those brackets is x plus 2x, so that'd be 3x. Negative 3 minus 4 is negative 7. Once again, I do a little spot checking and say, well, if I distribute this 1/2, I'm going to have 3 over 2 and 7 over 2. That's going to be hard to deal with later on. So I'm just going to go ahead and multiply both sides by 2. So we're going to take this side and multiply it by 2. And then we'll take that left side and multiply it by 2. That will give me 20 equals the 2 times 1/2 cancels out, gentlemen, which equals 3x minus 7. Add 7 to both sides, and you have 27 equals 3x. And you'll have x equals 9. It looks like Songha was correct, or we're both terribly wrong. Yeah. I think we're right, too. I have good faith in it. All right, guys. I'm going to go over homework questions, but I want to say something before I completely forget. Hey, next Monday, we're going to start constructions. That means if you look down your supply list for this class, you needed a compass and a straight edge. Next Monday, you will need that compass and you will need that straight edge. Real quick. This is a compass. All right, don't buy the most expensive one they have in the store. All right, it should just cost a few bucks. All right, I don't want to see $100 ones. I mean, if you want to, go ahead. Also, don't buy the cheapest one. Don't buy the one that's like 50 cents, because you're going to find in class it's going to be really hard to use. It's going to fall apart, and you're going to be constantly fixing it. All right, so don't buy the cheapest one, and don't buy the most expensive one, because we're only using it for 2 weeks. And if you spend like $100 on something you're using for 2 weeks in a geometry class, unless you're really going to use it in the future, probably don't. And then it says straight edge. That just means ruler. This is also a straight edge. And if you forget or whatever, I do have ones that you can borrow, but you can't take them home, so you have to have one so you can do your homework. Yeah, pretty sweet. All right, that being said, what questions do we have from the homework from last night? There are all those dang proofs. First of all, how many lessons did we have with proofs? We just had this one. This is going to be the only one that has proofs on it. On the test, we will have probably just one proof on it. Do we have a large pool of proofs to pull from? No. It's going to be similar to the ones we did for homework. I'll put some more on our, you'll see there's some on the review, but they're kind of duplicates of the one from the homework. So you don't have a bunch of proofs you need to work through, but so when you get to the test, you most likely have seen it, and you most likely will be okay, at least understanding the concept of it. All right, saying that, what questions do we have from the homework? Oh, number 2. What was number 2? Was that proving it was a parallelogram? All right. I don't even know where it is. I'll find it. All right. I think I have it saved on my iPad. Moment. Number 2, where are you? There you are. All right. So it says given rectangle ABCD. On the test, draw pictures. Step number 1 is write your given. I'm not going to do that because I'm trying to pull through this. So it's a rectangle. What's the definition of a rectangle? Why is a rectangle important to us? Yeah. It's a quadrilateral with 4 90-degree angles. So we know because it is a rectangle that all 4 of these are 90 degrees. And my step 2 is going to already gear it towards what my answer is. I'm going to say the measure of angle A equals measure of angle C equals 90 degrees. I'm also going to put the measure of angle B equals measure of angle D equals 90 degrees. And that is going to be the definition of a rectangle. The definition of a rectangle is all your angles are 90 degrees. That is just what the definition is. So I applied it. All right, my step 3 is actually the answer. Yeah.
Can you just write all angles instead of like writing each letter, or do you want each letter?
So here's the problem with yours. You didn't specifically say that the angles across are congruent. I have a specific statement that says, hey, the angles across equal 90 degrees. All right, now you look at your theorem sheet. And you do have 4 theorems that prove something's a parallelogram. That is theorem 5.4, 5.5, 5.6, and 5.7. What theorem says that if angles across are congruent, it is a parallelogram? Yes. Is 5.6? So we can then say ABCD is a parallelogram. Because of theorem 5.6, because theorem 5.6 says if your angles across are congruent, then it is a parallelogram. Is that good, Davion? I think so, because you're working on your homework now. All right, other questions? Yeah?
8.
8. Do you have a specific question?
No, I just need to run through it.
Do you just want me to show the answer and then say how I got everything?
Yeah.
Okay. All right, so number 8 gives us a whole bunch of information, right? It gives us that ABCD is a parallelogram. It gives us that AD is congruent to CE. So maybe I'll write that down. So it says AD is congruent to CE. And it gives us that CED, which is right here, is congruent to CDE. See these? I'm going to immediately probably just say that that's congruent, whether I need to or not. I'm going to at least think that. So I think that's my first step, is by the converse, I said DC equals CE, which means AD equals DC, correct? Mm-hmm. All right, now we have to prove that it's a rhombus. To prove something's a rhombus, you just have to prove that all 4 sides are congruent. So I already have this one's congruent and that one's congruent. And I know the shape's a parallelogram. So if AD and BC are compared, what do we know about both those? They're congruent. And then what about AB and DC? Did I just show that all 4 are congruent?
Yeah.
Then I proved it was a parallelogram. I just need to say that all 4 of these are congruent, and then by definition of rhombus, it has to be a rhombus.
Oh, okay.
That's it. You just had to show all 4 sides were congruent.
Okay.
That's it.
Yeah.
Probably just overthought it.
Yeah.
Yep. Other questions from the homework? Yes?
For the proofs in general,
Mm-hmm.
if it's like a rectangle or like if it's when it's a rectangle, do you have when you state that like the opposite sides are congruent, could you just say that there's the definition of a rectangle?
No, you say theorem 5.1.
So you have to like relate.
You still have to give theorem 5.1.
You have to say it's like a
You don't have to say it's a parallelogram.
but you like treat it as a parallelogram.
You can treat it as a parallelogram, yes.
So you can't say the definition. So the definition.
The definition only says that there's 4 90-degree angles.
That's it.
So if you ever say definition, the other side better say 90-degree angles.
Yes.
All right? If you're using anything that's applying to a parallelogram, then use theorem 1, theorem 2, theorem 3. Does that make sense?
Yeah.
And you can say it's a parallelogram, but you don't have to. It's just we already proved it. Yeah, Krupa.